Hello students, myself Kasale PB, Junior College Teacher, Department of Mathematics from Rayat Section Samsthas, RBNB College, Srirampur. Students, in the 11th standard we have seen definition of derivative and obtained derivative, methods of derivative by obtaining various functions, and also we have seen the rules of differentiation. Now today we have to recall definition of the differentiation, then standard formulae for derivatives and some rules of differentiation. Okay, now first we see here definition of derivative. Definition: if x and x plus h belongs to the domain of the function, f of x, and limit h tends to 0, f of x plus h minus f of x upon h is exist, then function f of x is said to be derivable or differentiable function. And this limit is said to be derivative of the function. This limit is said to be derivative of function f of x, and it is denoted by f dash of x. Therefore, we can write here f dash of x is equal to limit h tends to 0, f of x plus h minus f of x upon h. This is the derivative of the function f of x at x equal to x. If we take x equal to a, then this becomes f dash of a equal to limit h tends to 0, f of a plus h minus f of a upon h. Okay, and this is also called as first principle formula. By using this first principle formula, we can find the derivative of various functions like constant function, exponential function, power function, trigonometric functions, and so on. Okay, now we see here some standard formulae or derivatives of some standard functions. We know that number first, we suppose constant function k, d by dx of k, derivative of constant function is equal to 0. Okay, number second, d by dx of power function x raised to n, derivative of power function x raised to n is equal to n into x raised to n minus 1. Okay, number third, d by dx of e raised to x, this is exponential function. E raised to x means exponential function, derivative of e raised to x is e raised to x. Okay, again second function, exponential function, d by dx of a raised to x, derivative of a raised to x is a raised to x into log e. Okay, now next is trigonometric functions. We know that there are 6 trigonometric functions. For example, we can write derivative of first function sin x, derivative of sin x, that is d by dx of sin x is equal to cos x. Again we can write the derivatives of all trigonometric functions. Derivative of cos x is minus sin x, derivative of tan x is sec square x, derivative of sec x is sec x into tan x, derivative of cot x is minus cosec square x, derivative of cosec x is minus cosec x into cot x, and so on. Okay. Also we have seen standard formulae for the inverse function. Derivative of, we know that inverse trigonometric functions are sin inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x, and cosec inverse x. These are also standard formulae for the inverse trigonometric function. We know that derivative for sin inverse x, that is d by dx of sin inverse x, is equal to 1 upon under root 1 minus x square. Again we can write the derivatives of remaining inverse trigonometric functions, that is cos inverse x, tan inverse x, cot inverse x, sec inverse x, cosec inverse x. All these are standard inverse trigonometric functions. Okay. Now in 12th standard we have seen composite function. We have to see here first what is meant by composite function, and then we can write the formula for composite function. Now derivative of composite functions. Now we know that composite function means, first we see here simple function. We know that y is equal to sin x is a simple function, or y is equal to e raised to x, also simple function, or y is equal to x raised to 9, this is also simple function. All these are simple functions. If we write instead of x any other function here, then this function becomes a composite function. Like this, if we change this x, y equal to sin of, instead of x we can write here a raised to x. Okay. Now this is simple function and this is the composite function. Now we have to find the derivative for this composite function. Again this is a simple function, and y is equal to, if we write here e raised to sin x, instead of x we can write sin x here, then function becomes e raised to sin x, and this is a composite function. Also here also we can write, this is simple function, y equal to x raised to n is a simple function. We can write here y is equal to sin x raised to 9. Instead of x we can write here sin x, then this becomes a sin function, composite function. Okay. Now we have to find the derivatives of all these three composite functions. For this we can use composite rule for the finding derivative of all these three composite functions or various composite functions. Okay. We know that composite rule is, first we see here shortly composite rule. Composite rule, or we can say chain rule. If y is a differentiable function of u and u is a differentiable function of x, then we have to prove that dy by dx is equal to dy by du into du by dx. Okay, this is called as composite rule. By using this rule we can find the derivatives of various composite functions. Okay. Now first we write here formula for composite function, derivatives of composite functions. We know that there are 21 formulas, standard formulas. If we write instead of x in standard formula, instead of x we can write f of x, then this function, these functions becomes composite functions, and we have to find the derivatives of these composite function by using formulae. We write here formulas. Derivatives or formulae for composite functions. derivatives of composite functions. Now first we see here power function, standard function, power function, dy dx of x raised to n. Instead of x we have to write here f of x raised to n. This is the composite function, composite power function. Okay, derivative for this function we can write here n into f of x raised to n minus 1 into derivative of f of x, f dash of x, or we can write here dy dx of f of x. This is the derivative of composite power function, f of x raised to n. Again, second function, trigonometric function, dy dx of sin x is a simple function. Instead of x we have to write here f of x. This is a composite function. We have to find derivative for this composite function. Dy dx of sin of f of x means derivative of sin x is cos x. We can write here cos of x means we can write f of x into derivative of f of x is f dash of x or dy dx of f of x. Okay. Again we can write here second trigonometric function dy dx of cos of f of x. Instead of x we can write here f of x. F of x means any function. Derivative of cos of x is minus sin x. Therefore we can write here minus sin of f of x into derivative of f of x, that is f dash of x or dy dx of f of x. Again, number fourth, we can see one another example. Trigonometric function dy dx of tan of f of x. We know that derivative of tan of f of x, derivative of tan of x is sec square x. But instead of x we have to write f of x here. Therefore derivative of tan of f of x is sec square of f of x into derivative of f of x, that is f dash of x or dy dx of f of x. Now we see exponential function here. Number 5, dy dx of e raised to f of x. E raised to x is a simple function. We write here instead of x f of x, then this function becomes composite function. Derivative of e raised to f of x is equal to e raised to f of x into derivative of f of x. We write dy dx of f of x, or we can write only f dash of x, dy dx of f of x. Now one more function is here dy dx of a raised to f of x. We know that derivative of a raised to x is a raised to x into log a, but derivative of a raised to f of x is a raised to f of x into log a into derivative of f of x, that is f dash of x or dy dx of f of x. Now also we see here derivatives of inverse trigonometric functions, composite inverse trigonometric functions. Number 7, dy dx of sin inverse of f of x. Now sin inverse x is a simple function and sin inverse of f of x is a composite function. Derivative for this function is 1 upon under root 1 minus, instead of x we can write f of x bracket square into dy dx of f of x. Okay. Similarly, we can write the derivatives of cos inverse of f of x, tan inverse of f of x, cot inverse of f of x, sec inverse of f of x, derivative of cosec inverse of f of x, and also we can write derivatives of remaining all standard functions. Okay, we have to use these formulas for finding the derivatives of various composite functions. Okay, now also we have to know the rules of differentiation. We have to use various rules for finding the derivatives of the functions.